So with that, I would like to go ahead and welcome Gokhan Danabasoglu, who is the chair of the US AMOC Science Team, and he will be giving our presentation today for the webinar. So let me turn this over to Gokhan. Go ahead.
Okay, thank you, Kristen. And I'm guessing that everybody can hear me fine. So good morning and good afternoon for some of the people on the East Coast side, I guess. So I'll try to give you a brief update on the US AMOC Science Team activities. We have a web page connected to US CLIVAR.org, www, it's given here. And US AMOC Science Team represents an US interagency program supported by 4 agencies, and they are given here: NASA, NOAA, NSF, and DOE. In other words, these are the agencies that are funding the AMOC-related proposals. So what I would like to do is, oops, it's not advancing for some reason. Now, okay. So just brief outline of this presentation. For those of you who are not familiar with the US AMOC Science Team, I would like to give you a brief background on our objectives, our organization, and a brief history as well. This is essentially our 10th year of the US AMOC Science Team. I'll then show a few examples of some of the ongoing projects and recent results. And this is, I can't make, I'll show only a few examples. There are quite a few projects going on. And then I would like to conclude with current and planned Science Team activities that particularly emerged from our meeting in Santa Fe that we had in May of earlier this year. So the US AMOC Science Team has, from the beginning, had 4 objectives, and they are listed here: implementation and evaluation of AMOC observing system, assessment of AMOC state, variability, and change, assessment of AMOC variability mechanisms and predictability, and finally, assessment of the role of AMOC in global climate and ecosystems. I neglected to mention that AMOC stands for the Atlantic Meridional Overturning Circulation, if you are not familiar with that. Currently, when I say currently, I believe that's at the start of FY17, we have 58 funded projects supported by the 4 agencies that I mentioned. And the projects become sort of members or participate in the AMOC Science Team, and they are designated by the agency managers. So agency managers, when they fund a particular project, they decide whether it's essentially related to the US AMOC Science Team activities, and then the PI and co-PIs are invited to be members of the science team. So this is our organization. As I said, the main entity is the science team, and it consists of the PIs, co-PIs, postdocs, and students performing AMOC-relevant research, as I said, designated by the funding agencies. So this is a bit of broader scope than in earlier 2-3 years ago, for example. We only had the PIs included, but now it's much broader. Then we have task teams, and if you notice, these task teams essentially simply parallel what the science team objectives are. I showed 4 objectives here, and pretty much for each objective, we have a task team. The first one is focusing on observing system implementation and evaluation. The second is the state variability and change. The third focuses on mechanisms and predictability. And the fourth one is related to climate sensitivity to AMOC, looking at, for example, climate ecosystem impact. So this is our current task team structure and current number 4. And each task team has a chair and vice chair, and the current member or current leadership is listed here. These are the vice chairs and chairs serve 2-year terms, 1 year as the chair and 1 year as the vice chair. For example, Magdalena is serving as the vice chair this year, and starting in October, that's when our rotations occur, Magdalena will be the chair, Femke will rotate out, and then we'll seek for new, in fact, in a month or so, we'll seek for new nominations for the vice chair positions for all of these task teams. As Kristen indicated, I'm the chair of the science team. Along with myself and these leaders of the task teams, chairs and vice chairs, form the executive committee for the AMOC program. So as the executive committee, we are charged with identifying research needs to achieve the program objectives. We are encouraging and developing research activities to address these needs. We are involved with coordinating ongoing US and whenever possible international. We have quite close collaborations, particularly with the UK RAPID program internationally, research activities to address the program objectives. We are also providing, and I'll show you examples of this thing in a few minutes, summarizing the state of science and program progress. Then whenever we are requested, we are developing inputs to AMOC program reports as necessary. So just a brief history for those of you who are not familiar. As I indicated, we are in our 10th year. In 2007, AMOC was identified as a near-term priority by the Joint Subcommittee for Ocean Science and Technology, and within the same year, an implementation plan was developed. Actually, in March 2008, US AMOC Science Team was formally formed, and we had our first annual meeting in 2009. Starting in 2011, we started to have joint meeting with the meetings with the UK RAPID program, and they are listed as sort of light green color here, and they have been alternating between US AMOC Science Team meetings and international US AMOC Science Team meeting international that way, and then we also rotate between UK and somewhere in the US as seen here. During the 2012-2013 timeframe, we had an external review of the program, and that's available from our website, and we implemented, I believe, most, if not all of their recommendations. So this is sort of our current, this was the meeting list till 2015, and as you are aware, I think in late 2015, we were requested or asked to go to an 18-month schedule with our meetings. So what we did is essentially, in 2016, we did not have a formal US AMOC Science Team meeting. Instead, we essentially sort of encouraged people to participate in an ongoing workshop that was already planned, that was workshop on connecting paleo and modern oceanographic data to understand AMOC over decades to centuries. That was in Boulder. So we just had our fifth, I believe, US AMOC Science Team meeting. That was in Santa Fe, and I'll talk about it a little bit more in a few minutes. Our next meeting, so this is not really history, this is future at this point, joint meeting with the UK RAPID program will be in July 2018, and it's already essentially scheduled for that date, and it will be in Miami. We chose East Coast for easy, sort of relatively easy travel for our European colleagues, so that they can get their most participation. So these meetings, these workshops actually have been extremely useful for the US AMOC PIs and co-PIs, students and postdocs, because it essentially provides a really great venue for discussion, start of collaborations, exchange of information. And for US AMOC program, an important thing is essentially communicate our findings in a timely way. So workshops actually, or meetings serve that purpose. In addition to that, we have regular science team reports. And initially they were annual, 2013, 2014 are shown here. But with the switch of our sort of meetings to an 18-month cycle, we decided to follow the same cycle for our reports. So from 2014, our next report was actually published in 2016, September 2016. So we are essentially going to publish our next report in spring of 2018, roughly 18 months after this report. So we'll be sending requests from requests to PIs to send us their summaries. These have been really useful, not just for the PIs, but also program managers essentially funding these AMOC activities to see progress, or these also identify near-term and long-term gaps so they can essentially decide how to proceed and fund certain projects. Another avenue for communication for us is we have semi-annual, roughly, task team telecons. Each task team that I listed, they hold their own individual telecons, essentially led by chairs and vice chairs. They discuss new emerging science questions. They discuss near-term priorities and assess progress towards the AMOC and task team objectives. In addition, this was instituted also a webinar series by Task Team 3. It started in March of 2016. We have roughly monthly, I believe, except the summertime. Initially, we started as a Task Team 3 related topics, and they have been really popular. They have been really well attended, and you can essentially see that the list of the sort of presentations here. We are archiving both the video presentation and the PDF file of the presentation, so if people are interested, and they can take a look at what's going on. In fact, one of the outcomes and discussion topics of the Santa Fe meeting was essentially this sort of webinar series was being really very, very useful for the AMOC community, and we will continue this. In fact, we'll expand it to include contributions from other task teams, not just Task Team 3, and we'll likely continue, again, our monthly schedule. But if there seems to be actually quite a bit of interest, so we may actually go to maybe 2 presentations every 2 or 3 weeks, but we haven't decided that yet. So with that, I would like to just show a few sort of recent results and some ongoing projects, initially from observations. As many of you probably aware, there is a rapid MOCA array at 26.5 degrees north in the North Atlantic, and it is providing us estimates. Oops, I don't know what's going on. With the estimates of AMOC transport and its components continuously from 2004, this particular plot is roughly till the end of 2016. It's covering an 11.5-year time segment, and the total transport is shown by the blue lines, and the geostrophic component is shown by the red line here. The smoother lines are 90-day sort of running averages, and then the more sort of the noisier lines are essentially show the 10-day means. So it's interesting. I mean, you can see that there was a major event that happened essentially. In fact, in the 10-day average, AMOC actually reversed at 26.5 degrees north, and there is a major reduction in the AMOC amplitude. This is partly due to the phase change of the NAO, but there were also associated changes in the deep and intermediate depth southward flow of AMOC that resulted in this dip. So if you look at this sort of time series at just face value, essentially you can perhaps say that there is some decline of AMOC seen here. But perhaps another interpretation, perhaps a better interpretation of this plot is that prior to this 2009 drop of AMOC, we are seeing essentially a larger AMOC transports, and after this event, it appears to be the case that AMOC transitioned to a slightly weaker quasi-equilibrium state. Of course, I mean, I'm using this thing a little bit liberally here, but you can see that these are the associated annual mean transports. Initially, it was order of 18.6 square drops during the 2004-8 period, and if you look at a 2011 and 15 period, it is down to 15.7, and it's rather consistent sort of here over the last 5 years. And of course, there's a corresponding reduction in the heat transport from roughly 1.3 perawatts to 1.17 perawatts. So that's not insignificant in terms of reduction in the heat transport. So I would like to point out that, the point that I'm going to come back here, there is actually a reduction in AMOC strength at the latitude of the rapid array based on their calculations. So another program that we are really excited about, it's relatively new, is the Osnap program that represents the overturning in the subpolar North Atlantic. I listed some of the objectives of the Osnap program here. It is essentially quantifying the subpolar AMOC and its intraseasonal to intraannual variability via overturning metrics, including associated fluxes of heat and fresh water. So they are going to look at the pathways of the overflows, for example, to investigate the connectivity of the deep boundary current systems, and determine the nature and degree of subpolar subtropical AMOC connectivity. The entire observing system was deployed in summer of 2014, and initial sets of data have been recovered and they're already calibrated, and I think initial results are in progress. In the latest, in our Santa Fe meeting, that was the message that we received. So we should expect some initial results coming out really soon. I wanted to show you also another time series. This is from MOVE array. That's the Meridional Overturning Variability Experiment. This is at 16 degrees north. Now, what this array is essentially doing, it's measuring the southward transport at the deep western boundary current region below, I believe, roughly 950 meters and to the west of the Mid-Atlantic Ridge. So this is not the full transect across 16 degrees north, but it's only a southward segment. That's what it's trying to do. The point that I wanted to make here is that these transports are negative, meaning that, the transport is southward. So that's what I was highlighting in the rapid transport. For example, during the segment that the rapid array is actually showing a decline of AMOC, MOVE array is actually showing an increasing trend in AMOC. This is partly due to how MOVE and rapid folks essentially come up with these estimates, because they use different techniques, different methods, but they actually looked at it a little bit more detail. Even if they use the same method to compute the transport, this discrepancy still exists. They boiled it down to the differences in the western boundary at 16 and 26 degrees north, how they compute the transport in that region can impact the transport trends. The reason I wanted to point this out, this is an important, essentially, near-term priority. Even though we have all these observations, it's important to understand the latitudinal coherence of AMOC, essentially. We need to essentially be able to explain why one area is showing a decline and the another area is sort of indicating an increase of AMOC. One other thing that I wanted to highlight is, as I tried to allude to in the previous discussion, there are estimates of observations, but they are not necessarily measuring the same thing in the same way. And it is difficult to essentially use them in a consistent apples-to-apples comparison. So Task Team 1 essentially tried to create a web page providing links to available AMOC time series observations. It is essentially, these are links, and I wanted to highlight, for example, line W here. Another array that we have in the South Atlantic is the SAMOC Samba array, and that's a relatively new one. But you can see some information here, participants, and what is available from when. That's at least providing a one-stop sort of shop to connect to these data sets. Then you can connect to them. So I'm going to come back to this issue of certain discrepancies among these data sets at the end. From the modeling side, I wanted to show you, I'm partially biased, of course, to this work for some reason, but anyway, give you examples of sort of broader activities. One of the sort of near-term priorities or science questions of AMOC Task Team or Science Team is essentially try to figure out try to come up with representation of AMOC, the state of AMOC over the last 50 or 60 years. So we are doing it from the forward modeling side, and we're also doing it from the reanalysis side. This is an example from 20 or so models course, with the intraannually varying atmospheric data sets. That's coming from the coordinated ocean ice reference experiments. And it is showing AMOC time series as anomalies from the means given here from 26.5 degrees north. That's the rapid site, which is given here by the gray line here, rapid time series. It's rather short here. And this is at 45 degrees. The dashed lines show the multi-model mean. I mean, of course, there are differences among the models, but the main message is that after a relatively sort of stationary negative anomaly of AMOC here, there is an increase in AMOC till mid-1990s from about mid-1970s or late mid-1970s also, and then there's a decline of AMOC. So if you look at a similar measure from reanalysis products, this is what we get. This is now showing the AMOC maximum anomaly time series from reanalysis products at a certain depth, in this case 1,000 meters. The top is 45 north, the bottom is at 26.5 degrees north, and the reanalysis products are given here with their means. Some of the reanalysis products also have what we call no assimilation integrations, in which what they did, they essentially used the same forcings in everything, but they did not ingest any data, and those are shown here. So you can see that if you do not do any data assimilation, there seems to be more agreement among the models, reanalysis products. But if you start ingesting data, and most of these reanalysis products are essentially ingesting the same data. However, depending upon the details of the reanalysis product or fidelity of their model, you can get completely different trends. For example, OIRA S4 is saying that AMOC is declining during this period, whereas some other products are not showing any change, and some others do show an increase of AMOC. We essentially did an analysis, for example, of these things, what it is due to, and it comes out to be, it's because of essentially geostrophic component of AMOC. What is shown here is that, to give an idea about the hydrographic similarities, temperature, salinity, and density model average correlations are shown here in the upper 250, between 250 and 500 meters, and so on. You can see that even, I mean, as expected, there's more temperature data being ingested by the model, so there's more agreement, particularly in the upper ocean, in their temperature representation. But due to lack of data in salinity, or not as much data in salinity, and as we go deeper and deeper, for example, we are seeing major disagreements among the models in their representation of or ingestion of salinity. I mean, this is coming down to essentially how the reanalysis products use localization, how they use representativeness error, and then what the fidelity of their forward model is. Because if there is no data, reanalysis products are heavily relying on the fidelity of their forward models. In any case, I mean, this is a near-term priority still for us to come up with a representation of AMOC, consistent, robust representation of AMOC from forward and reanalysis products. So with that now, I would like to show you some examples of what we are planning to do, starting with our science team meeting that just occurred in May.